Good afternoon, class. We are looking at trigonometric functions. Here's other trigonometric functions or properties of trigonometric functions that we are going to cover. We covered angles and their measures, trigonometric functions, unit circle approach, and now properties of the trig functions. Objectives are find the domain, range, and the period of trigonometric functions. Determine the signs of a trigonometric function in the quadrant. Find the value of trigonometric function using fundamental identities. Find the exact values of the trigonometric functions of an angle given one of the functions and the quadrant of the angle. Use even odd properties to find the exact values of the trigonometric functions. So a quick recap of what we have covered. We have looked at the following definitions: vertex, line, ray, and so on. So here's a line. So you have two half lines. Each one is called the ray. They come together at this point. It's the vertex. So here's the vertex. You have two half lines. Here's the initial side. Here's the terminal side. And when it goes counterclockwise, that's positive angle. Here's the initial side. Here's the terminal side. If we go this way, clockwise rotation, it's a negative angle. Initial, terminal, initial, terminal. Now, so we discussed initial side, terminal, positive, negative, standard position. An angle is considered in standard position if its initial side is along the positive side of the x-axis. So this is along the positive side of the x-axis. So theta is in standard position and theta is positive. Theta is in standard position because the initial side is along the positive side of the x. However, this time theta is negative. Now, quadrantal angles, right angle, straight angle. Theta is a quadrantal angle. When the terminal side is located at one of the axes along the x-axis positive or negative, or y-axis positive or negative. This one would make it 0. This one would make it 90 degrees, 180 degrees, 270 degrees. Also, this is power 2, this is pi, this is 3 power 2. So one revolution counterclockwise gives you 360 degrees. There's the vertex, here's the initial side, here's the terminal side. Right angle, revolution counterclockwise. This is 1/4 of a revolution, 90 degrees. So this is a complete, this is 1/4. Terminal side, initial side, vertex, initial side, terminal side. So this is called straight angle. Half of revolution counterclockwise. It's 180 degrees, everybody. 180 degrees. It's very straightforward. U over 180 is r over pi. We know 2 pi radians is 360 degrees. 1 pi radian is 180 degrees. So One way to go from one format to the next, if the degrees are given, you can put it here, calculate the R. If the radians are given, put it here and find degrees. One degree is 60 minutes, 1 minute is 60 seconds. So you have a circle. This distance covered is called the arc length. S equals R theta. And the area of this portion of the circle is called area of a sector or wedge. A equals half of R squared theta. As we move in this direction, we create angular speed and linear speed. Angular speed, omega, it's not W, omega is theta over T. Linear speed is S over T. And going back to the angular, RPM stands for revolutions per minute. You multiply it by 2 pi to get it in radians format. S over T, and that's V also is equal to R omega. Recall, trig function is the unit circle. As far as a circle is concerned, centered at 0, 0 is x squared plus y squared equals r squared. When it's centered at 0, 0 with the radius 1, we have, this is the general case, x squared plus y squared equals r squared. And this one is specifically when the radius is 1, x squared plus y squared equals 1. Notice it has the intercepts at 1, 0, 0, 1, negative 1, 0, 0, negative 1. And that helps with the functional value of the quadrantal angles, and a pair P has coordinates x comma y with the unit circle. Sine becomes y, cosine becomes x. This is important to know. Sine is represented by y because it's y over r, and r is 1 for the unit circle. Cosine is x over r, and r is 1, just x. Tangent is the ratio of sine to cosine, so y over x. Cotangent, cosecant, secant are the reciprocal of those three. Cotangent is the reciprocal of tangent, cosecant the reciprocal of one sine, and secant is the reciprocal of cosine. If we go with the circle x squared plus y squared equals r squared, and P has coordinates x, y, we're going to go with a comma b, then sine theta, for example, which was y over 1 over y, it's y over r, because r is no longer 1. Cosine, which was x over 1, or simply x, now it's x over r, or a over r, and the rest of them follow in the same manner. We looked at exact values of a trigonometric functions for common arcs, power 6 or 30 degrees, power 4 or 45 degrees, power 3 or 60 degrees, and these are quadrantal angles, 0, power 2, pi, 3 power 2. And with that one class, just all you have to do, pay attention to this. For example, just for the sake of argument, if you look at this and the angle is 0, cosine 0 must be 1, sine 0 must be 0. Cosine power 2 must be 0, sine power 2 must be 1, and the rest of them follow. So this part is very simple. Just follow the unit circle. And hopefully you remember this from previous courses. We need to memorize the trigonometric functions of common arcs. Now, let's look at 5.3, properties of trigonometric functions, domain and range of trigonometric functions. We have it here, and I'm going to rewrite it here. Sine theta and cosine theta, the domain is all real numbers. The range is -1 to 1. Tan theta and cotangent theta, the range is all real numbers. Okay. Now, tan theta can't be pi over 2 or odd multiples of pi over 2. That's why all real numbers minus 2n plus 1 times pi over 2. 2n plus 1 means odd. Whereas cotangent theta, r minus n pi, just multiples of pi. And the reason is very simple. Tangent is sine over cosine, cotangent is sine over, cotangent over is equal to cosine over sine. Secant is 1 over cosine and follows that, and cosecant is 1 over sine. Secant is 1 over cosine. Cosecant is 1 over sine, and r minus n pi, it follows cotangent. And as far as the range is concerned for secant and cosecant, all real numbers except any number between -1 and 1. When we look at their graph, it becomes a little bit more obvious. So again, I'm writing that sine and cosine are between -1 and 1. That's the range. Cosecant can be less than or equal to -1 or larger than or equal to 1. Same thing for secant. Tangent and cotangent, no restriction when it comes to range. This is talking about the range. Determine the period of the trigonometric functions. A function f is called periodic if there is a positive number p such that wherever theta is in the domain of f, so is theta plus p. Therefore, f of theta plus p is equal to f of theta. If there is a smallest such number p, the smallest value is called the period or fundamental period of the function f. So what happens when we go 2 pi radians and beyond that, we have covered a complete revolution and we go back to wherever we were. For example, if we go 2 pi plus pi over 4 is the same as pi over 4 as far as the location for the terminal side. Therefore, for sine and cosine, the period is 2 pi. So in general, 2 pi times k is any integer. So sine of theta plus 2 pi k is sine theta, cosine of theta plus 2 pi k is cosine theta. And by the way, we may write 2 pi k or 2 pi n. In k, it represents an integer. Now, as I mentioned, you go a complete revolution and back to pi over 3. Okay. So pi over 3 and 2 pi and pi over 3 have the same terminal side. And therefore the same value for the sine and cosine. In the case of a tangent, because it is the ratio of sine over cosine, in the first quadrant, both of them are positive, so is tangent. In the third quadrant, both of them are negative, and negative over negative is positive. So for that reason, the period for tangent becomes only pi, and cotangent follows the same thing. Therefore, the period is 2 pi for all trigonometric functions except tangent, and with tangent goes cotangent. Remember, sine, cosine, secant, cosecant. They have the same period, namely 2 pi. And that's the smallest one. And then you can multiply, you can pick multiples of that. Finding exact values using periodic functions starting with sine of 17 power 4. When you see this number larger than 2 pi, just take out 2 pi or multiples of that. You may recognize this as pi over 4 plus 16 pi over 4, okay? So that means plus 4 pi. And 4 pi is a multiple of 2 pi. It's 2 times 2 pi. So the answer is sine of pi over 4, which is square root of 2 over 2. Cosine of 5 over 5 pi, and 5 pi is larger than 2 pi. So it's the same as 4 pi plus pi. Again, you go 2 complete revolutions, and then you end up at pi. And you know over here, cosine of pi is -1 because cosine corresponds to the x coordinate. And this point has coordinates -1, 0. -1, 0, and therefore cosine pi is -1. Tan of 5 pi over 4 is larger than pi. 5 pi over 4 is larger than pi. So pi plus what number? So this is -1. So -1. And this one is larger than pi by pi over 4. So it's the same as tan of pi over 4. And tan of pi over 4, we know it to be pi 1. Determine the sides of the trigonometric functions in a quadrant. Remember, cosine is represented by x, sine is represented by y. That's the key. So over here, this point has x, which is positive, y, which is negative. X squared plus y squared equals 1. P has coordinates x and y. And x for a unit circle. For a unit circle. This is cosine t. This is sine t. So in this case, x is positive. That means sine is positive. That means cosine is positive. That means, of course, x is positive. Y is negative. That means sine is negative. We can figure out the rest. Tan is the ratio of these two. If one of them is negative, and it doesn't matter which one, tangent becomes negative. Cosecant has the same sign as sine theta, negative. Secant has the same sign as cosine, positive. Cotangent has the same sign as tangent, also negative. So that's pretty straightforward, everybody. Now, you really don't have to memorize this because it's pretty straightforward, and we should know how to figure this out. The simplest method, as I mentioned, is just remember x cosine, y is sine. Therefore, in this case, all of them are positive. When we go to second quadrant, y is positive, so is sine, and with sine goes cosecant. In this one, x and y are both negative, so sine and cosine are both negative, but tangent and cotangent are both positive because the ratio of two positive numbers or two negative numbers makes no difference, is positive. In the fourth quadrant, x is positive, so cosine is positive. Y is negative, so sine is negative. So all of them are negative except cosine, and with cosine goes secant. So here's the sign: cosecant, cosine, secant, tangent, cotangent. And we have this. Again, you can memorize this or just remember the relationship between x and cosine, y and sine. And then you don't have to really memorize this. Finding the quadrant in which an angle lies. If sine is positive, cosine is negative, name the quadrant in which the angle theta lies. If sine is positive, that means y is positive. So that means either the first or the second quadrant. If cosine is negative, that means x must be negative. And if x is negative, it's either the second or third quadrant. What's in common between these two? Quadrant 2. So the answer must be quadrant 2. Okay, so if you look at quadrant 2, P having coordinates x comma y, x is on the left side, negative, y is above, is positive. So we should recognize that fairly easy. Fundamental identities. We know x squared plus y squared equals 1. And on a unit circle, P has coordinates x comma y, where x is cosine theta, y is sine theta. Therefore, x squared plus y squared, meaning cosine squared plus sine squared, or sine squared plus cosine squared is 1. So just plug it into this. That's the first Pythagorean identity. Sine squared plus cosine squared equals 1. Most of you remember that from before. And now let's divide both sides by cosine squared. When we do so, sine over cosine is tangent, so this is tan squared, this is 1. 1 over cosine is secant, so this is secant squared. So we get tan squared plus 1 is secant squared. So that's one Pythagorean identity. This is the second one. Now we're going to go back to the original one, and we're going to divide both sides by sine squared this time. So what happens? This is 1. Cosine over sine is cotangent. This is cotangent squared. 1 over sine is cosecant. This is cosecant squared. Therefore, 1 plus cotangent squared is cosecant squared. 1, 2, 3 Pythagorean identities we should know, and we just proved. We've already discussed the quotient identities. Tan is sine over cosine, cotangent is cosine over sine. We've already discussed reciprocal identities. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. So these are considered fundamental identities, and hopefully everybody is comfortable with them. Find the values of a trigonometric function using fundamental identities. Find the exact value of all trig functions. Sine theta is square root of 10 over theta, and cosine is 3 square root of 10 over 10. By the way, both of them are positive. That means quadrant 1. Well, let's start with the identities. Tan is sine over cosine, so sine over cosine. It's a complex fraction. The denominators are identical. You can drop it. And you get square root of 10. Divide by 3 square root of 10. And that is 1/3. The rest of them are reciprocal. So we're going to use those three now. Cosecant is 1 over sine. So the reciprocal of this is cosecant. What is the reciprocal of this number? 10 over square root of 10. And 10 over square root of 10 equals square root of 10. Just quickly, I'll show you. If you multiply, if you rationalize this, you multiply by square root of 10 over square root of 10, you see that you get 10 squared. Let's just write it here. 10 square root of 10 divided by 10. Now, cosine is given, secant is the reciprocal of that. And just 10 over 3 square root of 10. Um, 10 over 3 square root of 10, or 1 over that. Okay, 1 over that. So 10 over, we're just writing the reciprocal. You can. So 1 over this. That's what this says. 1 over this, which means 10 over 3 square root of 10. Now 10 over 3 square root of 10, I hope by now we know that we can rationalize it. You should know 10 divided by square root of 10 is square root of 10. Okay. 2 over square root of 2 is square root of 2. I hope nobody knows that, just as an example. Okay. And so if tangent is 1/3, cotangent must be 3, the reciprocal of that. Find the exact value of each expression. We don't need the calculator. 1 over cosecant squared 35 plus cosecant squared 35. Remember, cosecant is 1 over sine. Therefore, 1 over cosecant is sine. Therefore, this is sine squared. One more time. Cosecant is 1 over sine. So 1 over cosecant is sine. We can replace it with sine. Sine squared plus cosine squared of the same angle. They add up to 1. Cosine over sine is tan, and these two angles are the same. Tan of power 3. My apologies, cotangent of power 3. And their difference is 0. So cosine over sine is cotangent. There you have it. Tan of Tony minus sine Tony over cosine Tony. This is tan Tony. Their difference is 0. Sine squared of power 12 plus 1 over secant squared of power 12. Again, secant is 1 over cosine. So cosine is 1 over secant. Let me just write. I want to make sure that everybody knows that. So, for example, if you have this one, you should know that. In other words, secant and cosine are reciprocals. Cosecant and sine are reciprocals. Cotangent and tangent are reciprocals. So this doesn't change. 1 over secant becomes cosine because this is squared is cosine squared. And sine squared and cosine squared, the same argument. This is called the argument or angle, adds up to 1. Find the exact values of the trig functions of an angle given one of the functions and the quadrant. We can use circles. Phi has coordinates x and y. Circle of radius r centered at 0, 0, x squared plus y squared equals r squared. So r is squared of x squared plus y squared. So you can find x. If you're given x and y, you can find r. And assign a value to 2 of the 3. Based on the value of a trigonometric function, calculate the missing variable, because 2 of them will be given, and use the formula for the rest, meaning if you look at this one, either x or y, meaning a and b, is given, or one of them with r. For example, if it's tangent y and x, if it's cotangent x and y, if it's sine y and r, if it's cosine x and r, if it's cosecant r and y, those are the given. And of course, the second method, as always, would be using identities. We know Pythagorean identities, we know reciprocal identities, and quotient identities. So use them as appropriate and come up with the answer. So here's an example. Find the exact value of all trig functions, and sine is given 2 over 5, cosine is negative, and we are going to use circles. I'm going to go with 2 methods, everybody. I'm going to show you both methods. First, let's discuss the quadrant. Sine is positive, cosine is negative. Sine is positive in the first quadrant and second quadrant. So this is a positive number class. Larger than 0. And cosine is negative quadrant 2 and 3. That gives you the quadrant, so you can figure out the sign as far as that one is concerned. Okay, just so these are the formulas we are using, of course, because we're going to go with the circle. And as I mentioned, it's quadrant 2 because 2 is in common between the two. And sine, we are going to use y over r, 2 over 5, and y is 2, r is 5. So that means r is always positive, okay? Y is 2, y is positive. We can calculate the x. X squared plus y squared equals 5 squared. So this is 4. This is 25. Subtract from 25, you get 21. So x squared is 21. X is plus minus square root of 21. In the second quadrant, x is negative 21. Since theta is in the second quadrant, x must be negative. So we have x 2. That's how it looks like. Let's find the rest of it. We got the sign, cosine x over r. This one over r, which is 5. So minus square root of 21 over 5. Tangent is y over x. Y over x, and x is minus square root of 21. I'm going to leave it for you to rationalize. I'm assuming everybody can easily multiply this. So all you have to do, multiply by square root of 21 over square root of 21 to get this. Okay, so I don't think there's any problem. Cosecant r over y, 5/2. Again, I'm not mentioning the reciprocal of sine because we are just using the circles, okay? Secant is r over x, 5 over the square root of negative 21. And again, you have to multiply this one by square root of 21 over square root of 21 to rationalize this. As far as the negative sign is concerned, we either put it in front of a fraction or in the numerator normal. If you put it in the denominator, there's nothing wrong with that. It has the same meaning, but it's awkward. Normally, we don't do that. And cotangent is x over y. That means this number over this number. So that's using circles. Ultimately, it's your choice, unless they ask you for a specific method. So the same question, we are going to go with the identities. And here's the identities, and we discussed the quadrant in the previous page. So quadrant 2, we know that. So because sine is given, we are going to use the first Pythagorean identity to find cosine. Sine squared plus cosine squared is 1. By the way, just for the sake of argument, class, you should know from here, for example, cosine is plus minus the square root of 1 minus sine squared, okay? So that really is an equivalent statement. You figure out the plus minus based on the quadrant, just as an example, and the same thing with the rest of it. And so if you plug in 2 over 5 and square it, you get 4 over 25. You subtract it from 1, you get 21 over 25. So cosine is plus minus the square root of that. We established the quadrant is quadrant 2. In the second quadrant, well, even here, cosine is negative. So keep the negative one, right? In the second quadrant is negative. You don't even have to say that it was given. Now, the rest is very easy. Tangent is sine over cosine. Let me erase mine. So tangent is sine 2 over 5 over cosine. It's a complex fraction. You drop the 5, you get 2 over square root of negative 21. You rationalize your afterwards. So if that's tangent, cotangent is the reciprocal of that. And again, I'm going to leave it for you to show that the reciprocal of this is that by rationalizing if need be. We showed some work in the previous page. The reciprocal of this is 21 over 2 square root of 21. We have a negative sign. And I showed you that 2 divided by square root of 2 is square root of 2. So that's how you get the square root of 20. Cosecant is 1 over sine, and therefore it's 5 halves. The reciprocal of secant is 1 over cosine, which is the reciprocal of this number, minus 5 over square root of 21. And again, rationalize, you get to this answer. Remember, you multiply by square root of 21 over square root of 21, you get this. Find the exact values of all trigonometric functions when cotangent is 1/3 and sine is negative. And I'm going to do both methods again. I'm going to use circles and I'm going to use identities. Ultimately, it's your choice class. Remember that. Unless they ask you for a specific method, you choose what to do. All right. So first and foremost, cotangent is positive. So that means quadrant 1 or quadrant 3. This is positive, right? Positive means either quadrant 1 or quadrant 3 because tangent and cotangent are positive in those two quadrants. And sine is negative. In quadrant 3 or quadrant 4. Remember, sine is like, think about the y coordinate, okay? Y is negative in the third and fourth quadrant. And so what's in common? Quadrant 3. So that's the first thing, understanding quadrant 3 and y. Now, if we want to go with circles, cotangent is x over y. And in the third quadrant, x and y are both negative, so minus 1 over minus 3. Please understand. 1 over 3 is the same as negative 1 over negative 3, okay? So you have x and y, x squared plus y squared equals r squared. Square each one and add them up. This is 1. This is 9. So r squared is 10. R is square root of 10. R is always positive, okay? And so Let's start with the easy one. Tan is y over x. So r is the square root of 10. Tan is y over x, or 3. Sine is y over r, negative 3 over square root of 10. Rationalize it. So cosecant is r over y. Square root of 10 over minus 3, and you put the negative in front of a fraction bar. You can put it at the top, even at the bottom, but that's not a good idea. Cosine is x over r. Cosine is x over r, negative 1 over square root of 10, and you rationalize it, you get to this answer. And secant is r over x. So square root of 10 over negative 1, which we write it as minus square root of 10. So this is using circle. Using circles. Let us use identities again. We discussed the quadrant is 3, and we're going to stick with that. These are Pythagorean identities, tangent, cotangent, those are the ratio, and the reciprocals. Pythagorean identities, quotient identities, reciprocals, okay? As far as terminology is concerned. All right, so if we are given cotangent, and if we use this one, we can find cosecant, and when we find cosecant, we can find a lot of stuff. So let's go with that. Let's go with 1 plus cotangent squared, or cotangent squared plus 1 equals cosecant squared. We are going to replace this with 1/3, and 1 over 9, and 9 is 10 over 9. And so cosecant is plus minus square root of 10 over 9, which makes it plus minus square root of 10 over 3. Sine is negative, so is cosecant. It's quadrant 3. It's quadrant 3. Sine is negative, and so is cosecant, and so you keep the negative sign, minus square root of 10 over 3. Now we are almost there. We have cosecant. We can get the sine, the reciprocal of that, sine theta and cosecant theta. So when you look at this, you should recognize they are reciprocal of each other. And again, this is minus 3 over square root of 10. You know how to rationalize. If cotangent theta is 1/3, tan theta must be 3 over 1, or simply 3. Again, go with the easy ones that we have. Now, to get to cosine, there are different ways. Here's the fastest way. We know tangent is sine over cosine, right? And I hope you recognize you can interchange these two by the fact that this is a cross product, right? If you cross product, tan theta times cosine theta is sine theta. Let me write that so you can see that. And therefore, cosine theta is sine theta divided by tan theta. And we have both of them. We have sine theta, put it in here. We have tan theta. So negative 3 square root of 10 over 10 and divided by 3, this cancels this one, and you get minus square root of 10 over 10. And what about secant is just 1 over cosine. So just flip this over. When you flip this over, minus 10 over square root of 10 is minus square root of 10. Again, remember, I showed you 2 over square root of 2 is square root of 2. So 10 over square root of 10 is square root of 10. Use even and odd properties to find the exact values of the trigonometric functions. All trigonometric functions are odd except cosine. And with cosine goes secant. Because cosine deals with the x-coordinate. The x-coordinate is positive in the first and fourth quadrants. Whether you're dealing with theta or minus theta, the x-coordinate is not changing. That represents the cosine. Therefore, if cosine is even, cosine of minus theta is equal to cosine theta, so is secant because it's the reciprocal. All of them are odd. And again, reminding you that odd means f of minus x is minus f of x. Even means f of minus x plus f of x, just to remind you. Okay, we want to find the exact value. Cosine of negative 60 is the same as cosine of 60. It's a common arc and it's 1/2. Sine of negative 390 is minus sine of 390 because it's an odd function. 390 is larger than 360, so we're going to take off 360. So it's the sum of 30 and 360. So it's the same as minus sine of 30. Sine of 30 is 1/2, so this is negative 1/2. Tan is an odd function. Tan of minus 37 power 4, it comes out as minus 37 power 4. And all you have to do, take out multiples of pi. And you notice that we can say this is power 4 plus 36 power 4. 36 power 4 is 9 pi. Doesn't matter even or odd because the tangent and cotangent, the period is just pi. Therefore, this is the same as minus tangent of pi over 4. You know tangent of pi over 4 is 1. So minus 1. If cotangent theta is negative 2, find cotangent theta plus cotangent theta minus pi plus cotangent theta minus 2. And we know cotangent has a period pi. Therefore, this is the same as cotangent, so is this one. So the answer is 3 cotangent theta, which means 3 times negative 2, and that's negative 6. Find the exact value of sine of 1, sine of 2, all the way to sine of 359 degrees. Starting with this one, when we say 359, just look at this one. 359 degrees is the same as negative 1 degrees. 358, remember, this is going 361 complete revolution. So 358 is the same as negative 2 degrees. 357, the same as negative 3 degrees, and so forth. So let's write. So what happens? Sine is an odd function. Therefore, sine of -1, we can change it to negative sine 1. Sine of -2, we can change it to negative sine 2. Sine of -3, we can change it to negative sine 3. And we come all the way to the middle, everybody. So sine 1 cancels out, minus sine 1. Sine 2 cancels out, minus sine 2. Sine 3 cancels out, minus sine 3. And this thing continues. This one cancels out this one. So the answer is sine of 180. And sine of 180, or pi, this is plus sine of 181. So that's, remember, that is 181, which we change it to negative 179. 181, the same as negative 179, which comes out. And so the answer is sine 180. Sine of 180, sine of pi is 0. We should know that. Find the exact value of cosine of 1 all the way to cosine of 359, and we are going to do the same thing. So cosine of 359 is the same as cosine of -1, 358 -2, 357 -3. And as you know, cosine is even. So cosine of -1 is the same as cosine of 1. Cosine of -2, the same as cosine of 2. This one is the same as cosine of 3. So what do we have here? Now, when we add them up, these two two cosine of 1, these two cosine of 2. These two cosine of 3. And this continues all the way to 179. There are 2 of them, and cosine of 180 is just 1. Now here's the interesting thing. 179 degrees is 180 minus 1. 178 degrees is 180 minus 2. We're going to write it in that fashion, and I'll tell you why in a moment. Because cosine of 180 minus 1 and cosine of 1, again, cosine of 1 and cosine of 180 minus 1, that means 179. They have the same reference arc in both cases, just to give you. So this one and this one. have the same reference arc, 1 degree. So that means they have the same value. However, this is positive because it's in the first quadrant. So this is positive because it's in the first quadrant. This is negative because it's in the second quadrant, which means this cancels out this one. This cancels out this one. All of them cancel out, and the only thing left is cosine of 180 degrees. Cosine of 180 degrees, we should know it's -1. Here's the last question. Example 10. From a parking lot, you want to walk to a house on the ocean. The house is located 1,500 feet down a paved path. So from here, 1,500 feet. That parallels the ocean, which is 500 feet wide or away. Along the path, you can walk 300 feet per minute, but in the sand on the beach, you can only walk 100 feet per minute. Yes. So we can go this way and that way, or we can go at some point, we use the sands. The time t to get from the parking lot to the beach house can be expressed as a function of the angle theta shown in the illustration, and it's as follows. So this angle, if you go here, the angle is 90 degrees. But before that, if you decide to walk in the sand, because this distance plus this distance, okay, versus this distance and this distance, depending on your speed, one may be better than the other. This angle is theta, and t of theta is 5, minus 5 over 3 tan theta over plus 5 over sine theta, and theta is an angle in the first quadrant, somewhere between 0 and pi over 2. Calculate the time t if you walk directly from the parking lot to the house. So this is 500 feet, everybody. This is 1,500 feet. Tan of theta is 500 over 1,500. Because think about y over x. Here's the y, here's the x. So 1/3. And so with that being the case, we calculate the r as follows. R squared is x squared plus y squared. That means three squared plus 1 squared, 9 and 1 is 10, and r is square root of 10. So here's what we have, everybody. Let's pay attention to that. So the x, rather than, you can use 500 and 1,500 and calculate r. Please understand, 500 squared plus 1,500 squared is the actual value, but the ratio remains the same if we go with 1, 3, and square root of 10. So going to this formula, we know the tangent, and the sine is y over r. Y over r. 1 over square root of 10. So use that. plug it into this. So t is 5 minus 5 over 3 times tan of theta. Tan of theta was 1/3. Plus 5 over sine. Sine is 1 over square root of 10. So this one is 5. As you can see, this is 1. So this is 5. As you can see, this comes up. So we get precisely 5 square root of 10. And 5 square root of 10, putting it into a calculator, is approximated by 15.8 minutes. 15.8 minutes. This is where the units come from.